Hi again. Today we're gonna see homogeneous system of linear equation and then followed by eigenvalues and eigenvectors and then Hamilton theorem. So up to this linear algebra will be completed. Okay, let's see that. Homogeneous system of linear equation, which is nothing but the constant will be 0, right? So you can see here, consider the following homogeneous system of linear equation in m equations. So the equations up to m of n unknowns. So the unknowns up to n. What is the order? M into n. That's it. So a11, a12, so up to a1n. Okay, x1, x1, x2 up to xn. This is the equation. Okay, this is just general equation. Procedures to solve the problems. First category is we need to change that matrix into Ax equal to 0. Nothing but A coefficients means A matrix. Okay, we have to write the coefficients, then we will get the A matrix, right? After that, a vector which is equal to 0, or else reduce a matrix to RE form, means row or column, echelon form, right? Or else take del A. Why we need to find the determinant value here means the constant is 0. So if we find the determinant value, we can easily say determinant A is equal to 0 or not equal to 0, right? So first we need to change the matrix into Ax which is equal to 0, right? Or else change the matrix to row or column echelon. Okay, or else take determinant value. This is the third category. Like we need to compare rank of A which is equal to number of unknowns. Okay, or else determinant A which is not equal to 0, that is non-singular matrix. If there is a positive thing, then there will be a negative thing. If this condition satisfies, means the solution is trivial solution. Okay. Rank of A which is less than number of unknowns, or else determinant A which is equal to 0 means it is a singular matrix, right? So determinant A is equal to 0. You can see here this is less than, so there is a negative and there is a positive thing. So the solution will be non-trivial or infinite solutions. So there is only two categories. Rank of A is equal to number of unknowns. Here rank of A is less than number of unknowns. Determinant A is not equal to 0, determinant A is equal to 0. Positive, negative, negative, positive. Okay. So if this condition satisfies, trivial solution. If this condition satisfies, non-trivial solution. That's it. Linear independent. What is this? Nothing but non-zeros. So for that, we are having a formula n minus r. N is nothing but equation. R is nothing but rank. That's it. So equations minus rank. You can see here and just categorize for both homogeneous non-homogeneous equation. Generally the equation will be Ax equal to B. If B is 0 means it is homogeneous. If B is a constant value other than 0 means it is non-homogeneous equation. We know that. So for homogeneous, just now we see that rank of A which is equal to number of unknowns. N means number of unknowns. Okay. Or determinant is not equal to 0. Positive, negative means trivial solution. Negative, positive means non-trivial solution, means rank of A is less than number of unknowns and or determinant A is equal to 0. So any condition, if it follows any condition means the solution will be non-trivial solution. Okay, see here B is not equal to 0 means there will be a constant. So if B has some constants means B will be appear here. Means rank of A bar B is here. Rank of A is less than rank of A bar B. What is this? If rank of A is not at all equal to rank of A bar B, so it is less than. If it is less than means just come to first category, that is no solution category. If it is equal to, just go to other two categories. If it is equal means just go to other two categories, like rank of A bar B is equal to rank of A, rank of A bar B is equal to rank of A. But these two things are equal to number of unknowns means unique solution. If it is less than number of unknown solution means infinite solution. That's it. Just consider this. Okay, let's see some problems. They have given one equation and they want us to find the lambda, and they have given two linear independent solutions. So independent solution, what is the formula? Equations minus rank. Three equations are there, 3. Rank is what? We don't know. Okay, two linear independent. So the answer will be 2. Just find the rank. Rank is what? 1. 3 minus 1 is 2, right? So here we have to put 1. So rank is 1. Okay. Then we have to find the lambda value. You can see here we just write the coefficients and we just form the matrix A, and we are taking the determinant here. So determinant which is equal to 0 because it is a linear independent solution, right? So linear independent means determinant equal to 0. This is a upper triangular matrix. You can see here along the elements means along the non-zeros I can easily form a triangle, that is upper triangle. So it is a upper triangular matrix. So we want to find the determinant value means just multiple the diagonal values. So you can see here this one I have written here lambda plus 1, and this one a square minus b square, right? A plus b into a minus b. Lambda plus 1, lambda minus 1. Lambda is a and 1 is b. Okay. So lambda plus 1, lambda minus 1, which is equal to 0. You can see here the two things, the lambda will be minus 1 and here the lambda will be plus 1. But what is the thing is we need rank 1, right? Because we found rank 1. So what is the value which forms the matrix to bring the rank as 1? Let's see that. If we put minus 1, here we put minus 1 means it will be 0. Here means it will be 0. Here means it will be 0. So these three elements will be 0 means only 1 is remaining, that is rank 1. 1 non-zero vectors means rows. Only 1 non-zeros. So the number of non-zeros are 1 and the rank is also 1. So we can't put 1 here because if we put 1 means here will come to 2, right? But we want 0 here. Then only we can get only 1 non-zero rows. Okay. Let's see the another sum. Rank of 3 by 3 matrix is 1. They have given the rank as 1. The homogeneous system of equation is Ax which is equal to 0. So they have given 4 options here. You can see here trivial, 1 linear independent and 2 linear independent and then 3 linear independent. They have given 3 by 3 matrix and the rank is 1. Right, okay. If it is 3 by 3 matrix means how many equations are there? 3 equations are there. Rank they have given 1. So 3 minus 1 is 2, which is nothing but 2 linear independent solutions. But you can see here we need to find which solution, right? We need to find which solution this system is follows. So for independent solution means rank or is less than n, means equation should be less than n, right? Rank is less than equations, means r should be less than, then only the vectors can be said as linearly independent vectors. So you can see here rank is 1 and the equations are 3, right? So 1 is less than 3, so it is an infinite solution. So this we are just checking the solution. Okay, so infinite solution is nothing but these are all infinite solution. But how many infinite solution we need? 2 infinite solutions. So we are checking first the numeral number and then we are checking the solution here. Okay. Next question. They have given some equations here and we need to find which system of solution will be follow here. Okay, we need to find the solution. So they have given non-trivial, unique non-trivial, phi non-trivial and infinite non-trivial. They have given the equations here. Just copy the coefficients, you will get the matrix. And I am just taking the matrix which is equal to 0. So I am just taking the determinant. You can see here 2, 1, 1, 0, 1, minus 1, 1, 1, 0. So just put 1 here and 2 here, 1 here and 0 is 0 here. Then along these lines will be minus, just the product will be minus, and along these lines the product will be plus, right? So I am just making the things here. The determinant value is 0. If determinant is equal to 0 means it is nothing but infinite and non-trivial solution. Okay? Yes. So option D is correct. Infinite and non-trivial solution. Find the value of k. We need to find the value of k. Okay. For which the following system of equation have infinite number of non-trivial solution. Infinite number of non-trivial solution which is nothing but the determinant value will be equal to 0. Yes. And we need to find the k. So they have given the equations. 3 equations here. We just need to put here and then we need to change this to what form? Ori form, right? So first we need to make these 3 things as 0. How we can make? Just R2 minus R3, the same. R3 implies R2 minus R3 means we will get the same thing, right? And we need to make this element also 0, then only we can easily form the upper triangle, that is RE form, right? Okay, just R3 implies R3 minus R2. If we minus these 2 elements means we will get 0 here. Okay, so you can see here all are zeros, means we need only 0 here, but the thing is these 2 elements are equal, so here also we got 0. Okay, fine, we don't need to worry. Then we need to find k value. How can we find the k value? Just this coefficient into x, this one into y, this one into z, which is equal to 0. Likewise we need to substitute, but here you can see 3k minus 11 minus 3k plus 11 means if we add these things it will be 0, right? So we don't need to get this, means we don't need to take this. Let me see that, I will tell you. So I am just taking the first one. You can see here 3k minus 8, 3, right? So 3k minus 8 plus 3 which is equal to 0. I am just taking the whole row. So this one plus this one plus this one which is equal to 0 and this one plus this one which is equal to 0. So these are the coefficients. We don't need to put x, y here. Sorry for that, because we need to find the k value, right? So this one plus this which is equal to 0. Any one we can take. But if we take this means the whole value will be 0, so we can't find anything. But if we take this means we can easily find the k value. You can see here this is 6, so minus 8 plus 6 is nothing but minus 2. So 3k minus 2 which is equal to 0, k will be 2 by 3. Okay, let's move on to next sum. Find the real value of lambda. We need to find the value of lambda. Okay, for which the following system of equations. Okay, this system has non-trivial equation. They also given that non-trivial. So what is the meaning? Del is equal to 0, right? Yes, del is equal to 0. You can see here they have given 3 equations, but don't need to confuse here because this is a homogeneous. Why? They have given the constant, they have given the variables here. You can see here x, y, z. This is not constants, this is variable. You need to bring this to here. So this is x coefficient. So here I will get 1 minus lambda. You can see here, second one, there is a y coefficient is there, lambda. So 1 minus lambda. Likewise, I have to write the, what it is, A matrix. So this is the A matrix and I have to find the determinant value, right? I need to find the determinant of value, determinant of A, which is which is equal to 0, right? So I need to find the determinant value. How can I find the determinant value? By making this determinant into RE form, like 0, 0, 0, right? The same thing. Make these 2's as 0. How can I make these 2's as 0? Just multiply this by 2, multiply this by 3. You can get 6. So just subtract. You can get these 2 as 0. After that, just minus R3. R3 implies R3 minus R2. That's it. If we minus both the things, all will get 0. So we need to find, just add, and we will get the lambda value. Okay. Here you can see here, in both the case we will get the same value, I think. Yes, in both the case we will get the same value. Means the first thing, 1 minus lambda plus 2 plus 3, right? So 1 minus lambda plus 2 plus 3. Minus 2 lambda minus 7 plus 3 lambda plus 1. So minus 2 lambda minus 7 plus 3 lambda plus 1. You can see here, this is lambda and this one is minus 6. So lambda is 6. And here this is 5 and 6. So lambda is 6. So that's the thing. Next we will move to eigenvalues and eigenvectors. You can see here, what does the thing means? Homogeneous means dead easy. You no need to put so many calculations here, but it is a non-homogeneous means we need some calculations. Okay. Eigenvectors and eigenvalues. This is most important topic, because sure you will get the problems here. Okay. What is characteristic matrix? What is the characteristic matrix? Actually, A is a matrix minus lambda, which is nothing but eigenvalue. Lambda is eigenvalue. Into I. I is nothing but identity matrix. So this is a formation here. What is the characteristic matrix means? We need to write the A matrix in this form. A minus lambda into I. Then this will become characteristic matrix. If we take the determinant to this characteristic matrix, it will form characteristic determinants or characteristic polynomial. Okay. So it will form characteristic determinant or characteristic polynomial. Okay. The next thing is what? Determinant of, we need to make this determinant value equal to 0, means that is nothing but characteristic equation. Okay. So first we found characteristic matrix. After taking this characteristic matrix in a determinant, we will get characteristic determinants. After equating this determinant equal to 0 means it will become characteristic equations. Just remember this. It is somewhat like matrix. If we solve this means we will get a matrix like, right? So characteristic matrix. We are taking determinant mean characteristic determinants. If we are equating to 0 means this will become like equations, right? So characteristic equations, that's it. This is a trick. Next thing, we need to find the roots for lambda. This is nothing but eigenvalues, right? Okay. This is the eigenvalue. So eigenvalues or roots are nothing but taking the roots for lambda. So we can easily say the lambda as characteristic roots because it has some roots, right? So these roots are called characteristic roots. And what is the name for lambda? Nothing but eigenvalues. Okay, let me move on to eigenvalues. Let A be n into n matrix. Okay, lambda be scalar. Okay, characteristic roots. Nothing but lambda has some roots. Okay, characteristic matrix is nothing but we are taking a matrix. If we take a determinant, it will bring us characteristic determinant. If we are equating this to 0 means it will be characteristic equation. Okay, clear. The roots of characteristic determinant is called eigenvalues. We need to find the roots for this determinant value. Like we will find the roots for lambda, right? So this is known as, the roots are known as eigenvalues or latent roots or proper values. So eigen is proper, right? So proper value, eigenvalues. We are forming the roots, so latent roots. That's it. So eigenvalues has two more names here. Set of eigenvalues are called spectrum of A. Means we are finding three or four eigenvalues, means there is a set, right? A set of eigenvalues is nothing but spectrum of A. Okay. What is eigenvectors? Eigenvectors is nothing but, you can see here, lambda is what? Eigenvalue of A matrix. Okay. But here we need to know, in this sum, means in this condition, A is a matrix and it has eigenvalue as lambda. In this condition, there will be non-zero vector will exist. What is non-zero? Nothing but there will be no zero element in this vectors. That vector is named as eigenvector. Okay, you can see here, by using the non-zero vector we can make a relationship Ax which is equal to x lambda. This is the relationship. So this x is a non-zero vector which is nothing but eigenvectors. Okay, let's move on to next one. By using this equation, relation Ax which is equal to x into lambda, right? By using this we are forming some other relation, like we can see here Ax which is equal to x into lambda. This is a thing. We are multiplying by I as extra here. Then only we can form some other equation here. So by multiplying it by I, we can easily form A minus lambda t. Lambda I. I is identity matrix and A is a normal real matrix and lambda is eigenvalue, right? So you can see here A minus lambda I. Just take the x outside. This x is a non-zero vector which is eigenvector. So what is this? This is nothing but the characteristic matrix. That's it. So it is a characteristic matrix. So we are forming the characteristic matrix here by introducing I. Okay. So you can see here A minus lambda I into x which is equal to 0. Okay. This equation forms two solution, means trivial and non-trivial solution. We know that trivial means there will be negative. Bar means determinant of A minus lambda I which is not equal to 0 means it is a trivial solution. A minus lambda I which is equal to 0 means non-trivial solution. If it is equal to means non-trivial solution. Why? Just concentrate here. This part we are comparing only the characteristic matrix part. If characteristic matrix is not equal to 0, it is a trivial solution. Why? If this is not equal to 0 means this will be equal to 0. Then only we can get 0 here. So x is 0. You can see here this characteristic matrix is equal to 0 means this x will be not equal to 0, right? Just opposite thing. If x is not equal to 0 means it is a non-zero vector, that is eigenvectors. That's it. For example, you can see here A, I have given a matrix here and x is 1 1 which is not equal to 0. Okay. We are multiplying Ax to form the equation. You can see here Ax which is equal to x into lambda. So just the thing, we are forming the equations. Ax, I am just multiplying. Just multiply like 7. First row, first column. And second row, first column. Just 7. I am just multiplying here. This is just for identification, you have to multiply like 7, right? So okay, so first row, first column, 3 into 1 plus 2 into 1. Okay, 2 into 1 plus 3 into 1 means 3. So I am just taking the values here. Just take the 5 outside. You can get the same vector, which is nothing but x into lambda. Lambda is 5 and x is a vector, which is a non-zero vector. But this vector can be different. It is not at all same for all sums. Okay, let me see that. And you can see here x is nothing but eigenvectors and lambda is 5 for matrix A. That's it. Let me see some other thing. I said, right, the vectors can't be same. If in the previous sum we have brought 5 5, right? 5 5, the vector is 5 5. So along the line there will be many points out there. Any point which is taken along the line, you can also set this as non-zero vector, that is eigenvector. You can see here we can take 2 2, 3 3, 4 4, 5 5 up to this, or else greater than this 6 6, 7 7. Along the line we can take any point or vector along the same vector, also eigenvector corresponding to the same eigenvalue. So what is the eigenvalue here? 5. So for same lambda is 5, we can take different eigenvectors. You can see here I am just taking the another matrix as A. This is x, means 1 6. So we need to multiply it along 7, right? So 3 into 1 is 3, 2 into 6 is 12. So 3 plus 12. 2 into 1 is 2 plus 3 into 6 is 18. So 2 plus 18. So this is the thing. You can see the vectors are not at all same, but the point will be along a line. So these points will form a line. So the main element, this is the main vector. So any point which can be taken along the line which is joining the main vector will be also the eigenvector for the same eigenvalue. So you can see here the vectors are not at all same, right? So the eigenvector for lambda 5 is nothing but 3 4. Okay, so we need to find the eigenvalue and eigenvector. Let me see that. Eigenvalue, we need to find that. This is the normal means a normal form to find the eigenvalues. A minus lambda I. This is nothing but characteristic determinant, which is equal to 0 means characteristic equation. So we need to find the characteristic equations. So A matrix minus lambda into I, which is equal to 0. We no need to put these calculation and all, because the first time I am just telling, just write the A matrix here. You know the A matrix, along the diagonal just write minus lambda alone, minus lambda along the diagonal. So 3 minus lambda, 4 4, which is same, and minus 3 minus lambda. Just we can come to these steps directly. Okay, for understanding I am just included this step. Just you can came to this step. Okay, after that just take the determinant value, this into this minus this into this. So if you are taking the determinant value, we will get lambda is plus or minus 5, right? So you can see here the lambda is plus or minus 5. But what is the easiest trick? Just concentrate. Is what they have given a matrix. They need to find the eigenvalue. Okay, we need to find the eigenvalue. Sum of eigenvalues. So this is the eigenvalue. Sum of eigenvalue is nothing but trace of A. What is trace? Nothing but sum of diagonals. Sum of diagonals in the matrix A. So sum means trace. Sum of eigenvalue, which is nothing but trace of A, which is sum of diagonal. Okay. Product of eigenvalue, which is nothing but the determinant of A. Okay. So what is the sum here? Sum is 0. 3 minus 3 is 0. Okay. So the eigenvalue sum is 0. What is the product of eigenvalue? We need to take the determinant. So 3 3s are 9 minus of 3 3s are 4 4s are 16. So minus 16. Okay. So we are adding this. We will get minus 25. Right. You can see here we always solve. We always put these symbols to solve the quadratic equations. So likewise, the product is 25 minus 25 and the sum is 0. How can we get this? If we want the sum is 0 as 0 means there will be same number will be means some addition or subtraction will be done to the same number, right? If we done something to the same number means subtraction is done to the same number, like 5 into 5 is 25. And if we adding these two numbers, I'm just putting 5 minus here because if we add these two numbers, it will form 0. That's it. So minus 25 is the product and the sum is 0. So what is the value? Minus 5, 5. This is dead easy. This is very much useful for the 3 by 3 matrix because the steps will be long, right? So sum of eigenvalue is trace. Product of eigenvalue is determinant value. Just take these two values. We will get the lambda value means eigenvalues. We need to find the eigenvectors. For this, we need to put a minus lambda I into x, which is equal to 0 means this is nothing but characteristic matrix into x, which is equal to 0. So I just already told you, just make the A matrix and the diagonals just add along in the diagonals just add minus lambda. You will get this form into x1 into x2. You can say here we have got two values for lambda, right? Because it is a 2 by 2 matrix. Okay. Lambda is 5 and lambda is minus 5. Just substitute these things here and you will get some equations by solving any one equation. One is enough because both are same, more or less same. If this equation is divided by 2, we will get this, or this equation is multiplied by 2, we will get this. So more or less same. So just take the simple equation, one single equation. After that, which is equal to 0 means just put these two here. So x1 4x2 which is equal to 2x1, right? So x1 by x2 is what? 2 by 1. That's the thing here. The same procedure follows here, minus 1 2. That's the thing. So for lambda equal to 5 we have got two vectors because it is a 2 by 2 matrix. So for 5 value we have got this vector and for minus 5 value we have got this vector. Okay. So some notes are here. We already studied that A is said to be orthogonal only A transpose will be equal to I, right? So the same things applies here. x1, x2, there are two vectors. Two vectors are said to be orthogonal only x2 into x1 transpose will be equal to 0. And x1 into x2 transpose will be equal to 0. Like you can see here, the best example is this. x1 into x2 transpose means this is row 1, this is row 2. Like minus 1 into 2. If we multiply these things, we will get 0. You can see here 2, 1. And the transpose, if we multiply these things, you will get 0. So x1, x2 are orthogonal. Next thing is eigenvectors. Eigenvectors corresponding to different eigenvalues of real symmetric matrix are always orthogonal. So from this conclusions we concluded 2 points. So from these conclusions we have concluded 2 points here. Eigenvectors corresponding to different eigenvalues of real symmetric. Symmetric means orthogonal. If the eigenvectors corresponding to different eigenvalues of any square means linearly independent. Square matrix means linearly independent and symmetric matrix means it is orthogonal. Eigenvectors corresponding to eigenvalues. So eigenvector is orthogonal only if matrix is symmetric matrix. Eigenvectors are said to be linearly independent only the matrix will be square matrix. You can see here what is linearly independent, which means there is no connection between the two vectors, means x1 which is not equal to constant of x2. We have already seen that. And then third note, some eigenvalues are repeated. If some eigenvalues like 5, 2, 2, you can see here 5 is another one and 2 is repeating. So some eigenvalues are repeating means that vector is said to be, that vector may be linearly independent or may be linearly dependent. Next note, eigenvalues are repeated n times, means only the values are repeated means this vector is said to be linear independent only. Repeating values linearly independent. Okay. And the next note is ax which is equal to x into lambda. We know the equation. Okay. Lambda is what? Eigenvalues of A. Okay. X is what? Eigenvectors of A. Okay. How can we find A inverse? Nothing but just multiply A inverse here and here. If we multiply on both sides, A inverse into A is nothing but A. I. So this will become I. And this will become same. Right? Okay, this will become I. So x, just make this lambda here. So x by lambda which is equal to A inverse into x. Here you can see here x A inverse. The lambda will come down here. So x by lambda which is equal to x into A inverse. What is x by lambda? Just separate it, x into 1 by lambda. You can see here for matrix A, lambda is eigenvalue and x is eigenvector. For matrix A inverse, 1 by lambda is eigenvalue for A inverse and x is eigenvector. What it means x is same for both A and A inverse matrix. And A and A inverse eigenvalues are lambda and 1 by lambda. Okay. Let's see some properties of eigenvalues and eigenvectors. This is that easy because we have already seen that. Sum of eigenvalues is nothing but trace. Sum is trace. Okay. Trace means what? Just add the diagonal numbers. Product of eigenvalue is nothing but del, means determinant of A. Okay. For these matrix, upper, lower triangulars, scalar, diagonal, identity matrix, for these matrix, that the means we have already seen that determinant value will be product of the diagonals for these matrix, and for identity it is always 1. The same thing appears here for eigenvalues. For these matrix only its diagonal elements, we can take directly the diagonal elements as eigenvalues. You can see here this is same. Identity matrix is always 1, means the determinant value. The same here, the eigenvalues is also 1 for the identity matrix. So identity matrix always 1 as its eigenvalue. Okay. And the fourth point is eigenvalues for A and A transpose is same. Yes, A and A transpose has same eigenvalues. Okay. Eigenvalues for A and P inverse AP. A into P. Like we need to put PP here, and first one is the inverse and second one is a normal matrix. If this if this order is compared with the A matrix, means the eigenvalues will be same, because a matrix into its inverse A inverse is nothing but identity matrix. So this will become 1. So the eigenvalue will be same as A, right? So eigenvalue will be same. P is nothing but non-singular matrix. So P should not equal to 0. Eigenvalues of real symmetric matrix or real. Real symmetric matrix is real. Skew symmetric matrix is zeros. How? Because skew is nothing but diagonal will be 0, right? And symmetric is nothing but non-diagonal elements will be symmetrical. Okay, so eigenvalues of skew symmetric means skew means diagonal will be 0 and symmetric means non-diagonal will be non-diagonal symmetrical. Okay, non-diagonal will be symmetrical like Aij which is equal to Aji, like A31 which is equal to A13. Okay, 0 and imaginary. So this is real, imaginary nothing but I will come. Okay, so zeros and imaginary. Then 8th point, eigenvalues of orthogonal matrix or unit modulus. So if it is said to be orthogonal is nothing but x1 into x2 transpose which is equal to 0. This is orthogonal. Yes. So for orthogonal matrix, eigenvalues will be unit modulus, nothing but modulus of 1 which is 1 plus or minus 1. If lambda is an eigenvalue of orthogonal matrix, okay, then 1 by lambda is also one of its eigenvalue. For orthogonal matrix, it has some eigenvalue as lambda means there will be another eigenvalue as 1 by lambda. Like if 2 is eigenvalue for orthogonal means there will be another value like 1 by 2. It inverse. Okay, this is only possible for the orthogonal matrix. Next, the 10th point is eigenvalues and matrix. Just I have written the matrix here and the eigenvalues. You can just concentrate here. For A matrix, what is the eigenvalue? What symbol is we are using? Lambda. Okay, so for A matrix, it is lambda. A inverse means 1 by lambda. We have seen that. A constant into A means a constant into lambda. A square, lambda square, A per m, lambda per m. Just the trick is we need to make the lambda as A or A as lambda. Okay, just make the lambda as A, lambda and here A. 1 by lambda which is nothing but lambda power minus 1. So make the lambda as A power minus 1. So just make the lambda as A, K into A. Lambda as A square. Lambda as A per m. So this is a trick. Then for at J, for matrix at J, what is the eigenvalue? Del A by lambda. Okay, del A which is nothing but, so from this equation I have written here delta means, del, it is not del, it is determinant. Okay, determinant A which is equal to at J into lambda. So for at J matrix, what is the eigenvalue? Determinant of A by lambda. Then lambda plus or minus K, which is, just concentrate here, just make the lambda as A. As I have already told, lambda as A plus or minus K into I. Just into I. K into I. Just put K into I. This is our matrix and these are eigenvalues. From this also you can easily make here A to lambda and just remove the I. That's it. So lambda plus or minus K. For the matrix, this is the eigenvalue, and for the matrix A plus or minus K into I. If it is square, here also square. If it is minus 1, nothing but 1 by the part. Trick is always make to use lambda as A and A as lambda. If the constant is added means just make the matrix as constant into I. That's it. Okay. Let's see the another note. A is said to be singular matrix only determinant A which is equal to 0. We know that. Then 1 of eigenvalue will be 0. if determinant is 0 and it is a singular matrix, we know that, then one of eigenvalue will be 0. If it is an orthogonal matrix, then there will be 1 by lambda. We have already seen that. Let's move on to the problems. They have given one equation and they have given this. This is nothing but imaginary form. You can see here J is given like I or J. This is a imaginary form. They need us to find the sum of eigenvalues, which is equal to trace of A. What is sum? Sum is nothing but trace. So just take the trace here, sum of diagonals. Minus 1 plus 3 means 3 minus 2 is 1. Right? 1. Okay. We have brought it as 1. And we need to substitute the ij value as minus 1. So let's do that. You can see here these are the 4 elements. So 3 and just concentrate this first one. 3 plus 5 into minus 1, 6 into minus 1. So 3 plus 5 into minus 1, 6 into minus 1 is minus 1 into minus is plus 1. So I'm just substituting the minus 1 values in the j and I will get the value here. Just add all those values, you will get a value here. When it will come 1 means like it is same as trace. Why it is? These are the eigenvalues they have given. So sum of eigenvalues which is equal to sum of diagonals, right? So sum of diagonals is 1 and we are adding and we just got 1. So D option is correct. Okay. Then the next sum here they have given, they gave eigenvalues lambda 1 is 8 and lambda 2 is 4 and they have given eigenvectors mu 1 and mu 2. Okay. You can see here there is only 2 values over here. That means this matrix is 2 by 2 matrix. Okay. And they have given 4 matrix here. We know sum of the diagonals which is equal to sum of eigenvalues. So you can see here 6 plus 6 is 12. 8 plus 4 is 12. So we can easily click the first option here. Okay. If not means we have to use this equation because they have given eigenvector. This is non-zero vector, that is eigenvector. Okay, you can use this. The vector, they have given one vector, is an eigenvector of the matrix. Okay, so for A matrix, they have given one vector. And we need to find the eigenvalues corresponding to this vector is. What is the eigenvalue corresponding to this vector? They have given only one vector and we need to find the corresponding value for the one vector. A into minus means a minus lambda I which is into x. That means characteristic matrix into x is equal to 0. We know that characteristic matrix, just make the diagonal elements minus lambda. Just add minus lambda to the diagonal elements. You will get the characteristic equation into x which is equal to 0. And you can take anywhere, any equation. You can take this. I'm just taking the last one. So minus 1, minus 2, minus lambda, right? So just multiply it like 7. Minus 1 into 1, minus 1. Minus 2 into 2, minus 4. Minus lambda into minus 1, that is plus lambda. So lambda is 5. That's the answer. Just they have given only one vector and we need to find the other thing. It is dead easy, right? Okay. Let's go to the next sum. They have given one matrix. You can see here they have given one matrix, 3 by 3 matrix. Okay. But here they have given one variable. We don't know the value. Okay. This matrix has 3 eigenvalues, right? Okay. They have given one eigenvalue as 3 and they asked us to find sum of 2 eigenvalues, other 2 eigenvalues. Okay. We know that sum of eigenvalues which is equal to trace of matrix. What is trace of matrix? That is nothing but sum of diagonal values. You can see here 1 plus 0 plus p, that is 1 plus p, which is equal to, we know one value, right? 3. So 3 plus lambda 2 plus lambda 3, that is other two eigenvalues. So just make these values in the left side and bring all the things to the right side. So this is the answer for sum of two eigenvalues. The sum of two eigenvalues, we have found it. What can we do if they asked to find product of two eigenvalue? What can we do for that? Nothing but product of eigenvalue, which is equal to determinant of A. We know that. Okay. Just make these three values as a product. Okay. Means lambda 1 into lambda 2 into lambda 3, which is equal to the determinant value. I just took the center row. You can see here, this is plus symbol, minus symbol, plus symbol, minus symbol, plus, minus, plus, minus, plus. You can take whatever the row, but you have to use the sign. This sign is followed by the numbers. Okay, so I just take the second row. You can see here the second row. So 306. So minus 3 into, just make this row invisible. So you can see 4 elements are that, 2p minus 4. Likewise, and then minus 6 into just invisible rows. These two rows and columns are invisible. You can see the 4 elements. So 1 into minus 2, right? 1 minus 2. So by solving these values, you can easily get the product. The product of two eigenvalues is nothing but 2 into 1 minus p. That's it. Okay. Let's move on to the next sum. Matrix A, they have given one matrix and we don't know the value x, y. Like we need to find those values. Okay. And they have given the eigenvalue of A as 4 and 8. Okay. So we know two conditions, right? Sum and the product. So sum of eigenvalue, which is equal to trace, that is diagonal. So you can see here, sum of eigenvalue which is equal to trace, that is diagonal. Diagonal is what? 2y. So 2 plus y. And what is the sum of eigenvalues? 4 plus 8. So 4 plus 8 is 12, which is equal to 2 plus y. So what is the value of y? This is 10. Subtract 2 here, so the answer will be 10, right? Then we need to find x. For that we have to use product. Product of eigenvalue is what? Determinant of A. Okay. What is the product? 4 into 8 is 32. Okay. What is the determinant value? 2y minus 3x. This is that. Just substitute the value for y. You can easily get this 20 will come as this 20 will be subtracted to 32. You will get 12, right? So just cancel those things. You will get x is equal to minus 4. So x value is minus 4 and y value is plus 10. That's it. Let's move on to the second. Means the next question. The eigenvalue of 3 by 3 matrices, they have given 3 eigenvalues. Okay. Find trace of, they have given one complex, means one complex term, a square plus a inverse minus aj. How to find these things? First we need to find the bracket and then we have to substitute here. Let's see here. We know that they have given only lambda values. Okay, from lambdas we can easily get the matrix. What is a square? A square nothing but lambda square. What is A inverse? A inverse is nothing but the eigenvalues 1 by lambda. What is Rj? This is important. What is the matrix? What is the eigenvalue for the matrix Rj, which is nothing but determinant of A by lambda. Okay, we have to find the determinant A. Determinant A is nothing but product of eigenvalue, right? So what is the product here? 1 into minus 3 into 9, that is minus 27. Okay, we got it. Then I have written this complex term as in the center. You can see here a square is lambda square and plus a inverse, which is plus 1 by lambda, and minus at j, which is minus determinant a by lambda. We know that. Okay. After that, we have to substitute the lambda values here. Then only we can find this complex term. So what are the values? They have given 1, minus 3, 9, right? So for 1, we have substituted those values, we will get 29. And for minus 3, just substitute those values, you will get minus 1 by 3. And for 9, you will just substitute the values and you will get 757 by 9. Okay. Just see here, I have substituted the 1 here. So I have got 29. And I have substituted the minus 3 here. I have got minus 1 by 3. I have substituted 9 here and I have got 757 by 9. These are the values. But these are the values of lambda, right? These are the values of lambda. But we need to find the complex term as in the matrix. Okay, let's find that. Trace of these matrix, this is matrix, but we have got only eigenvalues. What is trace? Means sum. Trace of this matrix is nothing but sum of eigenvalues. So we need to find these 3 sums. Okay. Okay. Determinant of this complex. What is this complex? This complex is a matrix. So we have found the eigenvalues for this complex. So determinant means product of the eigenvalues. So it's nothing but you can just add it and you can just product it. You will get the answer. Okay, let's see the sum here. You can see here the eigenvalues of 2 by 2 matrix A are given by minus 2 and plus 3 respectively. Okay. The eigenvalues of x plus I, which is whole inverse, okay, into x plus 5i. Okay, they have given some equation here. Okay, we need to change this equation into a simple form, then only we can easily substitute this. Okay, how can I change this 5i? Just change this 5i as 4i plus I, right? Okay. So x plus I, the whole inverse, into, I just make this thing as x plus I plus 4i. I'm just separating here. You can see here x plus I plus 4i, x plus I plus 4i. Okay, I have done that. Just multiply these things inside. So a into means x plus I, the whole inverse into x plus I. I have written here. Plus x plus I, the whole inverse into 4i. Okay, I have written that. You can see here this is a common term, right? A inverse into A. What is A inverse into A? That is nothing but I. So this whole term inverse into this whole matrix means I. So I plus 4. Okay, 4 into I just took this I off because I is equal to 1, right, when it is in multiple. Okay, so I just take it out. So 4 into x plus I. You know that I need to change this matrix into lambda because they have given only the lambda values, means the eigenvalues. How can I change it into eigenvalues? What is the eigenvalue for the identity matrix? That is nothing but 1, right? Okay. So this is also 1, this is also 1. What is the eigenvalue for a matrix? It is just a matrix. What is the eigenvalue? That is lambda. This is a symbol. So I can easily write 1 plus 4 into, this is lambda plus 1, right? But here it is whole inverse. So I just keep these things. This is in numerator. I just keep these things as denominator. Okay, because of minus 1, the whole power minus 1. They have given 2 values here. So minus 2, we have to substitute it in the lambda value and you will get minus 3, and plus 3 we have to substitute here and we will get 2. So we have got two things as this complex. So we have found the eigenvalue of this complex equations. Okay, let's see some other sum. The eigenvectors of 3 into 3 matrix, they have given 2 eigenvectors. Okay, but we have to find one another vector, right? So they have asked what is the third vector, eigenvector. Okay, we need to find the third vector, but they have given this 3 by 3 matrix is an orthogonal matrix. What is orthogonal? Nothing but x means any two. This is for 2 by 2 matrix, any two vectors. Okay, so x1 transfers into x2 which is equal to 0 means it is orthogonal, right? So the same applies here. You can see here x1 transfers into x3. This is the unknown which is equal to 0. x2 transfers into x3. This is the unknown. We need to find the third eigenvector, right? So just make the x1 vector as transverse and then write the x3 vector as x, y, z because we don't know the value. So I just gave some variables here. The same applies here. If we solve this, means at like 7, you have to multiply it like 7. 1 into x, 0 into y and 1 into z. So x plus z equal to 0 and x minus z equal to 0, right? Just add these things, you will get the value for x and just substitute this x here and you will get the value for z. How can I get the value for y? You know here two elements are 0, but we know that eigenvector is a non-zero vector. It should have at least one non-zero element. So y should be another element other than 0. So y is not equal to 0, right? Because x is 0, y is 0. If x is 0, z is 0. If y is also 0 means it will be a 0 vector. Okay, so eigenvalue should have non-zero vector. So at least one should be a number. So y I have substituted as constant c. So what is the third element? 0, c, 0. This is the third, means it's not an element, it's the third vector. Okay, if I substitute, we can substitute any value here. If I substitute 1 means 0, 1, 0. That's it. Okay, let's see the another sum here. These sums are same like the previous one, so you can easily solve this. So for the time saving, I am just saying the another sum. Find eigenvalues and eigenvectors. So they have given one matrix. You can easily see here, if we draw a triangle along the numbers, it is in the upper side, so it is an upper triangular matrix. For the upper triangular matrix, the eigenvalue is nothing but the diagonals. So I have got the eigenvalues. How can I find the eigenvectors here? Oh, you can see here I have written some steps, like 4 steps. I will tell you how can I do that. Okay, then we will go to the steps. First thing, A which is equal to a matrix, right? So I need to write the first row here and the second row here. Yes, that's good. So I have to write the first row and the second row. That's the thing. I already told you for finding the edge A, like I need to select the center element. I need to go along a anti-clockwise direction. Yes, I do remember that. This is the anti-clockwise direction. So start with the center element and end with the central element. The same applies here. Start with 1 and go in an anti-clockwise direction and end with 1. But here there is a small change will be done, because along the diagonal elements you have to minus the lambda value. There are 3 lambda values, right? There are 3 lambda values. If we take the first lambda value, means you have to minus the lambda value in the diagonal elements while we are going in anti-clockwise direction. You can see, you can hear it. So start with center element and go in anti-clockwise direction. Why we are going in while we are going in anti-clockwise direction, there comes a diagonal, means you have to minus the lambda value to the diagonal value. Let's see that. Here is the first row, you can see it. So this is the center element 1. So start with 1, 1, 0, and I am coming to the diagonal value. So you can see here the first element, means I have found 3 values here, right? 1, 2, 3. Okay. So we need to find the first element. What is the first element? Means what is the first lambda value here is? Lambda is 1, right? So just concentrate on this. So I just taking the center value as 1, 1, 0. I am coming to the diagonal. So if I touch the diagonal, I have to subtract the lambda value, right? So 1 minus 1 is 0. So 1, 0, 0. Because 1 minus 1 is 0. 0 again 1. So 1, 0, 0 again 1. I am again telling you, just concentrate. The same applies here. Just pick the center element and go in an anti-clockwise direction, right? Just pick the second element and go in an anti-clockwise direction. But when you go in an anti-clockwise direction, there occurs any diagonal, means you have to minus this diagonal with, what is it? Lambda value. That's it. That's it. So you have to minus this is with lambda values. Like for the first thing, I gonna minus 1, minus 1, minus 1. I have to put minus 1, minus 1, minus 1 along the diagonal, right? Because this is the lambda value. Okay. So 1, 0, again here is what? 1. But actually lambda is 1. So 1 minus 1 is 0. So 1, 0, 0, 1. 1, 0, 0, 1. Let's go to the second row. You can see here, what is this? 2. Okay, I have to start with 2, but this is a diagonal element. So 2 minus 1 is 1. Okay. So 1, 2, 0. Again, I have to end in 2, right? So what is this? 2 minus 1 is 1. So here I have to subtract the each element by minus 1. Then only I have to write it here. You can easily, for your convenience, you can write it as, I have to subtract the diagonal elements by minus 1. Why I should subtract this? Because the lambda value is minus 1. So this will become 0. 2 minus 1 is 1 and 3 minus 1 is 2, right? Then you have to write the other elements here. Okay. If you look at this, it will be very easy for you. So start with the center element 1, 0, go in anti-clockwise direction and again 0 and 1. Okay. And this you can see 1, 2, go in an anti-clockwise direction and again 0 and then end in 1. So this is the thing. So I have written first row and second row. Just consider only 2 rows. Okay. Just return the center of these two elements as x1, x2, x3. So for finding x1, just multiply these two things. For finding x2, just multiply these two things. But write the answer as denominator. x1 by answer, x2 by answer, x3 by answer. You will easily get the vector here. Okay. Is this simple? Yes, it is. You can easily see here the next sum. Then the next value we have to substitute as 2, which is equal to 2. Lambda is equal to 2, right? So first I need to subtract these 2 in the diagonal values. If I subtract 1 minus 2 is minus 1 and 2 minus 2 is 0 and 3 minus 2 is 1, right? Okay. Then what are the remaining elements? 1, 0, 2, 0, 0, 0. Just go as it is. This is the center element. I have picked it and I am going in an anti-clockwise direction. You can see here 1, 0, minus 1 and 1. 1, 0, minus 1 and 1. And again I just picked the second element, I mean center element here. I'm just going anti-clockwise. 0, 2, 0 and 0, 0, 2, 0, 0. Just put x1, x2, x3 here. Just cross multiply each elements. You will get the answer as this vector. The same applies for lambda 3. Okay, what is lambda 3? I have to subtract this 3 in a diagonal value. You can see here 1 minus 3 is minus 2, right? 1 minus 3 is minus 2. Okay, and you can see here 2 minus 3 is minus 1, and 3 minus 3 is nothing but 0, and I have to write the remaining elements here, 0 and 0 and 0. Okay, I need to consider the first row and second row, right? I'm starting in the central element. Okay, 1 1 0 minus 2 and 1. Okay, and the next second row, I'm just picking the central element, minus 1 2 0 and minus 1. That's it. So simple. Then x1 x2 x3, I just have to write those variables in the center. Afterwards I have to cross multiply each element. I will get the answer. Just if there is simplification, means just simplify it and then write it as a final answer. You can see here, you can just make the same here. These are the eigenvalues, means lambda values. You just substitute 1 and then you have to find the remaining part. Like you have to go along the, just pick the central element and you have to go along the anti-clockwise direction. That's it. So okay, let's move on to the Clay-Hamilton theorem. Okay, what is the statement here? Every square matrix satisfies its own characteristic equation. How is this possible? Let's see that. Let me consider a matrix as A, 4 2 2 4, right? What is the characteristic equation? Nothing but A minus lambda into I, the del value, which is equal to 0, means this is the characteristic equation. For finding that, I already told you, if it is a lambda came, means just put the diagonal as element minus lambda. So 4 minus lambda 2 2. Just bring the determinant value here. You will get the answer as, what is the answer? No, you will easily get the characteristic equation here, right? You can see here. So this square, 4 minus lambda the whole square minus 4, right? So you can do some formulas here. I just done this is I just take this as A and this as B. So a square minus b square, which is equal to a plus b, a minus b. You can see here a is 4 minus lambda, and you can see here b is 2. So 4 minus lambda plus 2 means a plus b, a minus b, which is equal to 0. Just multiply it. I just simplify it. After that, 6 to 2 terms, lambda to 2 terms. I'm just multiplying it and I will get the equation as this. This is a complicated method, means it's a long method and it is an ordinary method, but Hamilton has find it some simplification here. That is, the square matrix always satisfies its own characteristic equation, right? Let me see that. So the same matrix I have taken here. Okay, this is the A matrix. Okay, this is the A matrix. Okay, what is the characteristic equation? Nothing but there comes a formula, lambda square. So always, because there will be 2 lambda values, so it is a lambda square minus of trace of A. Trace is nothing but sum of diagonal values. Okay, trace of A into lambda plus determinant of A. That's it, which is equal to, you can easily direct it in a single line. Lambda square minus, what is trace? 4 plus 4 is 8 lambda, plus what is the determinant here? 4 4 is 16 minus 4. 16 minus 4 is 12, right? That's it. So lambda square minus 8 lambda plus 12, which is equal to 0. Okay. So for 3 by 3 matrix, it is dead easy. You can see here there are 3 lambda values will be brought from the 3 by 3 matrix, right? So lambda cube minus lambda square into trace, the same thing, plus the determinant, means in the center we have to add some elements for the 3 by 3 matrix. What is that element? plus lambda into minus, I have already told you, m11, m22 plus m33. That's just the diagonal values. Okay, so we have to take the diagonal minors here. Minus lambda. For example, these, let me consider some matrix which is a 3 by 3 matrix. You can know that these are the diagonal elements. I have to find m11, m22, m33. You can see here this is m11, 1, 2, 2, 2, 3, 3. So for finding the m11, just make this row and column as invisible, and you have 4 elements, right? So 3 2s are minus 6, minus 1. So minus 6, minus 1. Okay, fine. Just make this row and column as invisible, write these elements here. This is somewhat a long step. Just you can do a mind calculation here. This is a central element, that is diagonal, a second element of diagonal. Okay, so by making this row and column as invisible, you can see there are 4 elements. So minus 2, this is 0, so just a minus 2. And for 3 3, minus 2, just make this as invisible. You can see the 4 elements. 3 plus 2 is 5, right? Sorry, 3 minus 2, 3 plus 2 here. Okay, so 3 plus 2 is 5, right? Right, so this is the answer. So these are the minus. Just add these minus here, you will get the lambda value. This is the characteristic equation. Okay, how to change this lambda into a matrix is dead easy. Just make the lambda as A, right? So A square minus 8A plus 12 into this. This is, remember this thing, lambda is 1 means it is an identity matrix. So 12 into I, which is equal to 0. This is the thing. Okay, they have asked another question here. We will move to the problems. A has a matrix which is 2 by 2 matrix, and we need to find the C, means characteristic equation. We have found that lambda square minus trace of A lambda plus del, plus determinant of A, right? You can see here. So how can I take these things? Lambda square minus trace is what? Just add these diagonal values. So minus 3, minus of minus is plus 3 lambda. Okay, plus 2. What is the determinant value here? 0 plus 2 is 2, right? Okay, I'm just converting it to the matrix. You can see here there is 1 A square. Just make the lambda as A square plus 3A plus 2 into 1, right? So 1 is for identity matrix. So 2 into I, which is equal to 0. Okay, we have found the equation, but you can see here there is, this equation is not at all in the options, right? You can see here, A option, B option, C option, D option. There is no such options over there, but this is the correct answer. You can see here they have oppositely given here 3A, but they have given 2A. This is obviously not true. And you can see here 3I they have given. This is also not true. You can see here explanation of A, so it is also not true. So the remaining option is here only. So we need to convert this equation into this form, right? How can I make this? You can see here, first take the center elements, because here 2 A's are there, right? So we have to separate this single element into 2, means 2A plus A. Just multiply I in the 2A. So I have written here A square, that is A square, plus 3A I have written here as 2AI plus A, okay, plus 2I, which is equal to 0. This is done. Okay, it's done. Next thing, I have to compare the first two things, and I have to take the A as outside. So I have taken the A as outside. You can see here A, which is equal to A into, here A come out, and A plus, here 2A come out, plus 2I. So A into A plus 2I plus I into, means just take the I here. We don't need to take actually A plus 2I, the same appears here. Just make I here, multiply by I, like here we have done extra, right? likewise we have to done some extra here I. After that you can see here a plus 2i, there are two same brackets, so that means we have to return it as single one, and then we have to combine the other two elements a plus I. So a plus 2i into a plus I, which is nothing but the third option here. Now we have gone to the final sum. You can see here the characteristic equation of 3 by 3 matrix is nothing but P. This is given by means alpha into lambda, don't consider this. This is a characteristic equation. You can see here lambda into I minus P, right? Lambda into I minus P. This is del value, means determinant, which is equal to lambda cube plus lambda square plus 2 lambda plus 1. What is this? This is a characteristic equation. Yes, where I is an identity matrix. Up to this it is a question and they have asked only P transverse. Okay, P transverse they have asked. What can I do for that? First thing I have to do is I have to convert it into a matrix, because they have asked only a matrix. So I just converting it P cube P square means like A. Okay, I'm just converting into P because they have asked only P, right? So P cube P square plus 2P plus here is 1. 1 is for the identity matrix, so I, which is equal to 0. Then what is this thing? P inverse. They have asked only the P inverse, right? So I need to find P inverse. Multiply by P inverse. If I multiply these things, I will get, like you can see here, P power 3 into P inverse. So P power 3 into P inverse means, just you can think here 3 minus 1 is 2. So just subtract it. 3 minus 1 is 2. So P square. 2 minus 1 is 1. So P. Plus you can see here this is A, this is A inverse. A into A inverse is nothing but I. So P into P inverse is I. So 2 into I plus I into P inverse. 1 into P inverse is nothing but P inverse, which is equal to 0. So from that, just take this P inverse here and make all the elements to the right side. You can get the answer easily. So P into P inverse, which is equal to I, and P inverse into I, which is equal to P inverse. From these two things we get this equation. And thank you so much for watching this. And what to say, up to this I have completed the linear algebra. So we have covered 6 topics, I think. So we have covered 6 topics. If you have any doubt in these topics, don't hesitate. Please do comment. Please give your valuable comments in the valuable questions in the comments. I do answer for the questions. Thank you so much for watching. Thank you. Bye bye.